Similarly, 750. These two elements are in order. That means 7 must come before the 15. So it is in order. So we need not to perform swap over here. Then 28 and 22. Definitely 22 must come before the 28. Then we will perform swapping. Then 36 and 4. Definitely 4 must come before the 36. So we need to swap. So after swapping, we'll get this array: 12, 7, 22, 4, 71, 15, 28, and 36. So that type of array we will get. Now we'll choose step number 2, that is we need to perform insertion sort. Right. So on that particular array, we need to apply insertion sort. So in this pass, what we'll do, we'll compare 12 and 7, we'll swap them. Then 22, 12, there is no need to swap. Then 4 and 22, yes, we need to swap. Then 4 and 12, yes, need to swap. Then 4 and 7, yes, need to swap. So at this stage, we'll get this array. Now k is equal to 5. So fifth element is 71. So 71 will be compared 22. There is no swapping required. Then k is equal to 6. The sixth element is 15. So 15 and 71, there is need to swap, yes. 15, 22 need to swap, yes. Then 15 to 12, no swapping required, right? Now we'll take the next element, that is 71 here. 71 will be compared 28. There is no need to perform swapping. Then 28, 28 and 71 will be compared. We will need to perform swapping over here. Then k is equal to 8 means last element. The last element will see 36. So 36 and 71 we need to perform swapping over here. So 71 and 36 have been swapped. So after swapping, finally we will see this array that is sorted: 4, 7, 12, 15, 22, 28, 36 and 71. So this is a way by which cell sort algorithm is working. I hope it is clear in your mind. If you have any doubt, you can chat. Is it okay? Is it easy to understand? Say yes or no. Is there any doubt? Shall I move ahead? Anyone? Am I audible? Say yes or no. Anyone type into chat? Am I audible, loud and clear? Now the next sorting algorithm is the, so first of all, try to understand the complexity of the shell sort, then we'll start the another algorithm. Thank you, Prasanjit, for replying. So the best case complexity, it occurs when there is no sorting is required. Definitely, that is, the array is already sorted. The best case time complexity of cell sort is order of n into log n. In average case complexity, it occurs when the array elements are jumbled ordered, that is not properly ascending and not properly descending. So the average case complexity of the shell sort will be n into log n square. The worst case complexity, it occurs when the array elements are required to be sorted in reverse order. That means suppose you have to sort the array element in ascending order, but elements are already in descending order. So that is the worst case time complexity, and that is order of n square. So you need to remember all these three complexities: best case, order of n log n. Average case, order of n into log n square. And the worst case, order of n square. Many times the complexity of the shell sort have been asked in all three cases. Now, merge sort. Merge sort is a very popular sorting algorithm that follows the divide and conquer approach. It works by dividing the unsorted list into smaller sublists, sorting those sublists recursively, and then merging them back together to obtain a sorted list. Here is how the merge sort algorithm works. So, three main steps are of merge sort. First divide, then conquer, and then merge. Divide, the unsorted list is divided into two halves, roughly equal in size. The division continues recursively until each sublist contains only one element or it is empty. Then, once the division will be completed, we'll start conquer. Each sublist is sorted individual using the merge sort algorithm. This is done by recursively applying the divide and conquer strategy. Then merge, the sort sublist will be merged back together to obtain the final sorted list. This merge process involves comparing the elements from two sublists and placing them into the correct order. Now try to understand with the help of example how merge sort works. So this is the algorithm of the merge sort. Step 1, if the list has 0 or 1 element, it is already sorted, return the list. Step 2, divide the unsorted into two halves. Step 3, recursively sort the two halves using the merge sort algorithm. Then step 4 is merge the two sorted halves by comparing the elements from each sublist and placing them in the correct order. This process is repeatedly until all elements are merged. And finally, in the step 5, return the merged and sorted list. So what are the steps in divide? What are the steps in merge? What are the steps in sorting? We will learn these three steps. So divide function, to divide the input list into two halves, then find the middle index of the list, split the list into two halves using the middle index. Middle index in that case 7, the example I'll show you. The left half includes the element from the start of the list up to the middle index excluding. The right half including the element from the middle index inclusive to the end of the list. Then recursively sort them. Recursively apply the merge sort algorithm to left and the right half obtained from the divide steps. Each recursive call will further divide the sublist until it reaches the base case. The recursive call will sort the sublist by merging them back together. The merge function takes two sorted lists as input and merge them into a single sorted list. It uses two pointers to keep track of current element being compared in each sorted list. By comparing the elements and appending them in the correct order, the merge function constructs the merge list. After one of the sorted lists it is fully processed, the merge function appends the remaining elements of the other list to merge the list. All these three steps I'll explain you with the help of example step by step. Just have a look into the next slide. So this is the best example of the merge sort that I'm going to show you over here. Here we are having 8 elements into the list. 5247, 1326. These are in the array. Now first of all, we are calling the merge function. Into the merge function, we are passing the array A, which is consisting 8 elements in unordered manner. We are passing the starting index, that is 0. We are passing the end index, that is 7. So merge sort is the function we are calling. A is the array. The starting index of the array is 0. The end index of the array is 7. We are passing this array into the merge function. Now what will happen? Just check it out. Recursively, this merge function will call again merge, 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 sort, merge, sort, merge, sort. So what will happen in that case? The array will be divided from the center into two halves. So first half will again call merge sort. The second half will again call merge sort. Similarly, recursively, it will be divided again from two parts or two halves, 2, 6 and 1, 3. Similarly, this will also call the merge sort again and will divide the array into two halves. Again, recursively, this array will be divided from the center and it will divide the array into two halves. So this merge function will call itself until we are not going to get either empty list or a list which is consisting only one element. Once we'll receive the one element into the list, the merge recursive call will be stopped. Then this will call the merge function. This will call the merge function. The merge function will merge two halves into single halves by sorting them. So it will be sort, then merge. Right? So this 5 and 2 will be merged, but before merging, they will be sorted. So 5 and 2, the order must be 2 and 5, right? So 2 and 5 will be sorted, then it will be merged. So after merging, you will see a list will be prepared 2 and 5. Similarly, this 4 and 7 will be merged, but before merging, it will be sorted. So 4 and 7, it is already into the sorted order. So 4 and 7 will be merged. Similarly, 1 and 3 will be merged. Similarly, 2 and 6 will be merged. Now, individually, all these lists are sorted. You can check it out. Right? Then again, merge function will be called. So merge function will merge these two lists, but before merging, it will sort. Right? So how the sorting process will be over there? From the first list, 2 and 4 will be compared. Whichever is the less will be merged into the another list, right? So 2 and 4, 2 is lesser than, so 2 will be inserted into the merged list. Then 5 will be compared with 4 and 7. So 4 and 5 and 4, 4 is small, so 4 will be inserted into the merged list. Then remaining element are 5 and 7. Then 5 and 7 will be compared. 5 is small, then 5 will be inserted into the merged list. Then the remaining element is 7, then the 7 will be stored into the merged list. So finally, a merged list have been compared and it is in sorted manner. 2, 4, 5, 7 are the sorted manner. Similarly, these two lists will be merged with the help of merge function. One will be compared 2 and 6. So 1 is small, 1 will be inserted here. Then 3 will be compared with 2 and 6. So 2 is small, 2 will be inserted. Then 3 will be compared with 6. So 3 is small, 3 will be inserted. Then finally 6 will be inserted. So this list is also a sorted list. Now these two lists are sorted. Again, the merge function will be called. So 2 will be compared 1 2, 3, 6. Right? So 1 is small, so 1 will be inserted here. Then this 2 will be compared with 2, 3, 6. So definitely any 2 can be inserted over here. So I'm just inserting 2 here. Then this 4 will be compared with 2, 3, 6. 2 is small, 2 will be here. Then this 4 will be compared 3 and 6. 3 is small, so 3 will be inserted. Then this 4 will be compared with the 6. So 4 is small, 4 will be inserted here. Then 5 will be compared with 6. So 5 is small, 5 will be inserted here. Then 7 will be compared with 6. 6 is small, so 6 will be inserted here. Then 7 will be pasted into this list. So finally, all the elements have been merged together. So this merging and sorting is completed. Final list that we are getting after merging, that is 1, 2, 2, 3, 4, 5, 6, 7. So you can see the complete array is sorted. So first we called merge sort. It is a recursive process. It will divide the array into two halves until we are not getting the single element into the list or null into the list. Once it will be done, then we will conquer them by sorting. So this is the merging process or conquer process by sorting we have seen. So this complete process is called merge sort process, where we have sorted the array by divide and conquer strategy. I hope it is clear in your mind. If anyone having any doubt can clear their doubt. Can ask the question and clear their doubt. You can ask your question by typing into the chat box. So what is the complexity of the merge sort? So merge sort complexity, time complexity is order of n log n in all the cases. There is no best, worst, average. In all the cases, in all three cases, best case, average case, and worst case, the time complexity of the merge sort is order of n log n, where n represent the number of elements into the input list. This makes merge sort efficient sorting algorithm, especially for the large input size. The main reason behind the merge sort time complexity is its divide and conquer strategy or divide and conquer approach. The algorithm divides the input list into smaller sublists, sort them recursively, then merge them back together. The merging process requires comparing and merging the element, which takes order of n times in worst case. Since the dividing step recursively divides the list into two halves, it takes the recursive algorithm always take, order of log n. So levels to reach at the base case. So as a result, the total time complexity of the merge sort can be expressed as a order of n log n. So log n, the complexity of recursively dividing, and n comparing and merging. So as the merging process is performed at each level of recursion, and there are log n levels. Now the last algorithm that we need to discuss is the quick sort algorithm. Before explaining the quick sort algorithm, anyone just type into the chat. You have any doubt in the shell sort or merge sort? Just check it out. This is the merge sort. Anyone having any doubt? Just say yes or no so that I can move forward. I can move for the next sorting algorithm. Do anyone having any doubt? how the merge sort is working. Done? Very important algorithm that is called quick sort. The name explains itself. It's quick. The similar complexity like merge sort, order of n log n. The same complexity of this algorithm, order of n log n. So quick sort is widely used sorting algorithm that follows the divide and conquer approach to efficiently sort an array or a list of elements. It was developed by Tony Hall in 1959 and is known for its average and best case time complexity, that is order of log n, order of n log n. This complexity makes it one of the fastest sorting algorithms. The basic idea behind the quick sort is to select pivot element from the array and partitioning the remaining elements into two sub-arrays according to whether they are less than or greater than the pivot. The pivot is the placed in its final sorted position and process is recursively applied to the two sub-arrays. The main idea behind the quick sort is the pivot element must be placed into the array at its right position or correct position as it must be in a sorted array. So this partitioning and sorting process continue until the entire array is sorted. It's a kind of unique sorted algorithm. Therefore, it is a quick sort algorithm. This algorithm includes two functions. The first function to set the pivot element at its correct position as it must be in a sorted array. And then finally, the complete array will be divided into two parts and repeatedly the quick sort will be applied. So in the first part of the algorithm that is called quick sort pivot algorithm. So in this first part of the algorithm, the first step is to choose the highest index value as the pivot element. That means if we are having an array, so just randomly choose pivot, or normally the first element we are going to choose as a pivot. Sometimes the highest index must be chosen as a pivot element. Sometimes the lowest index must be chosen as a pivot element. But normally we are going to choose the first element as a pivot element of the array. Then step 2, take two variables to point the left and right of the list including the pivot. And normally in programming language, in algorithm, these two variables we are choosing I and j, right? So we need to take two variables, left pointer and right pointer. So left points to the low index and the right pointer points to the higher index. While value at the left index is less than, the pivot will move right hand side. Remember, while value at the left index is less than the pivot, move to the right hand side. Similarly, while the value of the right index is greater than the pivot, move to the left side. In both steps, 5 and 6 does not match, swap left and right. Listen carefully. If both step 5 and 6 does not match, swap left and right. If left pointer is greater than equal to the right pointer, the point where they met is the new pivot element. The new pivot element. So finally, this is the first part of the quicksort algorithm to send the pivot at its the correct position. On the next part, going to start after doing that, quicksort algorithm. Similarly, repeat it again. Step 1, make the rightmost index value as a pivot, partitioning the array using pivot value. Then quicksort left partition recursively, quicksort right partition recursive. It is a recursive algorithm. It is a divide and conquer algorithm. It is a fastest algorithm. It is a based on the pivot value. Once pivot will reach at its correct position, the array will be divided into two parts. In these two parts, again, quicksort will be applied. Just try to understand the complete quicksort algorithm with the help of this example. In this example, we are taking an array. This array having 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are over there in this array. Right? As I told you, we need to store these elements into an array. An array is unsorted array. We need to choose the pivot element. In most of the cases, the first element we are going to choose as a pivot element. Here, the 54 will be the first pivot value that we are choosing over there. 54. The 54 will be chosen as a first pivot value. Then I told you we need to take two variables. One should be pointed to the left side and another will be pointed to the right side of the index. One should be pointed to the lowest index, another should be pointed to the highest index element. Normally, we are going to take I and J in program, right? So, the left mark and the right mark will converge on the split point. They will converge to the split point, right? So, if left mark value is less than the pivot, move to the left side. And the right mark value is greater than to the pivot, move to the, this will move to the right hand side, this will move to the left hand side. These are the left mark and right mark are the two variables. (26) is less than pivot, move. So it will reach to the 93. Then 93 is greater than 54, stop. So this left mark will stop here. Now right mark is at the 20 and the 20 is less than 54, then stop. So right mark will stop at 20. When right mark and left mark will stop, then swap these two values. So 20 and 93 will be swapped. 20 and 93 will be swapped. Again, we'll start. So 20 is less than the 54, move. 17 is the less than 54, move. 77 is greater than 54, stop. So this left mark will stop here. Similarly, the right mark will move. 55 is greater than 54, move. 44 is less than 54, stop. So 77 was greater than 54, so this left mark will stop. 44 is less than 54, then this right mark will stop. Then 77 and 44 will be swapped. So 44 is here, 77 is here. Now 44 is smaller than 54, move. Then 31 is smaller than 54. 77 is is greater than 54, then stop. And 31 is smaller than 54, then stop. Now you can see left mark and right mark have been crossed to each other. So once left mark and right mark will cross to each other, so you can find a next pivot element, right? So we will swap the 31 and 54. So you can see the 54, the first pivot have been reached at their final position as their actual position. This is all element less than 54. These are the all elements greater than 54. So the complete array have been divided into two parts, where 54 is at their correct position in sorting manner. All the elements greater than 54 are 77, 55, 93. All the elements less than 54 are 31, 26, 20, 17 and 44 at the left hand side of the 54. Then 77, 55 and 93 are the right hand side of the 54. Now the same process will be repeated recursively until the complete array is not going to be sorted. On that particular array, apply quicksort. Similarly, on that particular array, apply quicksort. Recursively. Right? Apply quicksort recursively. So once we will apply quicksort recursively, the same process will be repeated again and again. 31 will be pivot in that case, 77 will be pivot in that case, and again the same process will repeat it. So this is a way by which quicksort will work. Now, what is the complexity of the quicksort? I hope it is clear in your mind. If anyone having any doubt can ask the questions to me. It is little bit complex, but not too much. So you can understand it in a very easier manner. I can explain you it again if you want. The whole game behind that is the pivot element. We need to shift the pivot element at its correct position as it must be in a sorted array. So finally, 54 have been reached to its correct position, whereas all the elements greater than 54 are at the right hand side, and all the elements which are less than the 54 are the left hand side. Like quick sort again. This also quick sort again. Recursive. You can see here in this algorithm. Partitioning and partitioning recursively apply quick sort left partition, apply quick sort on right partition. Okay, now have a look towards the complexity of the quick sort. The time complexity of quick sort is generally expressed as a order of n log n. In the average case and the best case, however, in the worst case, it can be degraded up to order of n square. So average case and the best case, in the average case, the quick sort divides the input array in approximately two equal size sub-arrays during the each partitioning steps. This leads to balanced recursive tree structure, resulting in the time complexity will be order of n log n, where log n is the recursive algorithm, or the recursive algorithm is the log n, and order of n is to performing the pivot element, sending the pivot element at its correct position. So the logarithmic factor arises from the number of times the array can be divided in the half during the partitioning process. The best case occurs when the pivot is always chosen as the median element. In this scenario, the partitioning process produces two subarrays to nearly equal size at each step, leading to efficient sorting with the time complexity of order of n log. But in the worst case, the time complexity of quick sort will become order of n square, which occurs when the pivot is consistently chosen poorly. This can happen when the input array is already sorted or nearby sorted, and the pivot is chosen as the first or the last element in such case. The partitioning process may result in the high imbalance subarray, leading to poor performance. However, this worst case scenario is rare in practice. Overall quick sort average case and the best case time complexity is order of n log n, make it highly efficient sorting algorithm, often outperforming other sorting algorithm like merge sort or heap sort. Now we are just going to compare all the algorithms because you need to remember the complexity of these algorithms. Many times it have been asked in any kind of competitive examination and interviews, the complexity have been asked, right? So you must have a basic scenario, you must have a basic idea about the complexity of the different types of sorting algorithms. And you need to remember which algorithm is working on which technology or technique, right? So these are the comparison chart which will compare the multiple sorting algorithm with their technique and complexity. So criteria for the technique you can see over there. the criteria of bubble sort, selection sort, insertion sort, merge sort, and quick sort. So bubble sort uses the brute force technique, and the complexity, the worst case is order of n square. Average time complexity is theta of n square. The base time complexity is the omega of n. Space complexity is order of 1. It's a constant. Stable, yes, it is stable. It is used in place, yes, it is in place. That means there is no external storage is required for that. So this is not the external algorithm. It is in place algorithm. Selection algorithm, again, it is uses brute force technique. The worst case time complexity is order of n square. Average case time complexity is theta of n square. The best case time complexity is omega of n square. That means selection sort in all the cases, its complexity is n square, order of n square. The space complexity again is a constant space complexity order of 1. It is stable? No, it is not stable algorithm. It is in place algorithm? Yes, it is in place algorithm. But it is not stable algorithm. So sometime it have been asked which algorithm is stable algorithm, which is not. So you can say selection algorithm is not stable and quick sort algorithm is not stable. Remaining all algorithm are the stable algorithms. Only selection and quick sort are the not stable algorithm. Then insertion sort, again the technique used is the brute force technology. And worst case time complexity is the n square, order of n square. Average time complexity is theta of n square. And the best case time complexity is omega of n. And the space complexity, the complexity is very much similar to the bubble sort. The space complexity is the order of 1, that is complex. The constant space is required in that case. It is stable, yes, it is stable. And it is in place, yes, it is in place. There is no external memory required for that. Then merge sort algorithm. Merge sort algorithm uses divide and conquer technique. And quick sort is also uses divide and conquer technique. Worst case time complexity of the merge case is the order of n log n. In all three cases, best, average, worst, it will take order of n log n. Average case, theta of n log n, and best case, omega of n log n. In all three cases, it uses n log n time complexity. But in case of space, because it requires external array, extra space, therefore, space time complexity is order of n. N is the total number of elements in the array, because we need an extra array of size n, which requires for comparison and merging, right? Therefore, the space complexity have been increased over here in case of merge sort order of n. It is stable, yes, it is stable. It is in place, no. Why it is not in place? Because we need separate array in merge case. When check it out, we need a separate array, an extra array, because once we are comparing and storing, we require an extra array to merge it, right? You can see into this diagram also. Here, this is an extra array which needs to store, because 2 and 1 will be compared. So whichever will be less, we need to store into different array. So a different array, this is a different array, this is a different array. These are two different arrays. So to merge, we need extra space. Therefore, we can say this is not in place. This is in extra space is required for that. So this is not in place algorithm. This is stable, yes, and the space complexity is order of n in case of merge sort. Similarly, in quick sort, the worst time complexity is order of n square. Average and best time complexity is n log n in that case, in case of quick sort. Space complexity is order of n. And it is stable? No, it is not stable, because sometime it will be divided in between, sometime it will not divided into in between. So we can say it is not stable. It is in place. Yes, it is in place. No extra array is required over here. So this is the throughout comparison, the overall comparison of the different types of algorithm. After comparing, we get to know the quick sort will give us a best result in all the cases. Moreover, the merge sort is also good algorithm, but it requires some external memory, and it is not in place algorithm. And in average and best case, when the algorithm have been compared, so quicksort is performing better as compared to merge case. Both algorithms are using divide and conquer method. Both algorithms are using recursive method. Therefore, it is giving n log n time complexity. So finally, we are going to finish this lecture. Today's learning outcomes are in this session, we have discussed about the different types of sorting. We have learned about the shell sort. We have seen the performance of the shell sort algorithm. We discussed about the merge sort. We have seen the merging of sorted array. We have seen the merge sort algorithm. And finally, we discussed the quick sort algorithm and quick sort algorithm performance. And we have compared all these sorting algorithms, and we get to know that quick sort algorithm will play a best role. It's working on divide and conquer method. It is a recursive method. So if anyone having any query or doubt, may ask. Any doubt? Say yes or no. Anyone having any doubt can ask the query. I'm going to stop the sharing. I haven't received any queries, so I'm just going to leave from this lecture. Thank you guys. We'll meet again in the next lecture.